Hi, everyone. This is Kevin Limtow here to discuss my Project 7 system description. This is the project to develop a GPS location data streaming service of a kind from a Raspberry Pi to a host PC. The system described here is a combination of hardware and software to capture GPS data onto a Raspberry Pi, stream that GPS data via Wi-Fi to a host PC, and display that in some way, shape, or form. And really the overall goal here is to attach a GPS module slash receiver to a Raspberry Pi, mount that together onto a quadcopter, and stream that GPS data to a host PC. So really the stipulated requirements here from the course are to mount a GPS module to the quadcopter that we built back in Project 4. Also mount the RPI to the quadcopter. Again, that was actually the quadcopter built in Project 4, but the Raspberry Pi has already been mounted there from Project 6. We need to capture GPS data on the RPI, stream it to the host PC, and also display it in some way, shape, or form on host PC as well. And so some derived requirements, these are actually mostly not new. The first two derived requirements have to do with setting up a wireless access point to facilitate the GPS data streaming, and also use the motion software to facilitate live streaming of a web camera. We've already established the web camera from Project 6, so might as well add on to that functionality and not remove it from this project. So really, the motion and RASP app programs were already discussed in the previous project, so I won't go over those again. But the real key addition for this Project 7 is the use of a GPS module, and more specifically GPSD software, which is actually an open source service daemon that can monitor GPS receivers connected to a computer via USB, which is really handy here because the Raspberry Pi has plenty of USB ports. And then using a variety of different clients that actually come kind of prepackaged with the GPSD software, like XGPS, CGPS, or GPSmon. You can visualize the GPS data, and I'll have some examples of what that looks like in just a second. But there's a lot more information on that GPSD software that can be found at this link here. So the hardware setup for this project is very, very similar to Project 6. Again, as I said, the only real addition is the use of a GPS module for this particular project, so that way we can gather and display GPS data. And so that is depicted here as just a quick little block diagram, all centered around the Raspberry Pi. The software for this project, again, is completely off the shelf. There was really nothing that I developed for use in this project. As mentioned in the requirements section, we are still using the Motion and RASP app software programs, and now we have the additional GPSD software package, which I grabbed the latest release, which was 3.25, that was released earlier this year, January 10, 2023. One funny thing that I ran into, which gave me a lot of grief and headache, was even getting GPSD installed. And I actually realized that I was using the wrong Raspberry Pi OS for my given system. I'm using the Raspberry Pi 4, which is a 64-bit system. And I realized on Project 6, I was actually using the 32-bit OS version. And so that gave me some grief. For this project, I overhauled that. I basically just flashed on a completely new image using the Raspberry Pi OS Imager tool, and now I am up and running with all the same tools and all the same functionality as last week, with the addition this week of GPS. So as I said, a variety of different clients to be used, like GPSmon or XGPS, to visualize the state of the GPS module and the data it is receiving. And here's kind of an example of what that looks like. This is not my example. This is actually the example from the Canvas course materials, but in the demonstration section, I'll show you what that looks like when it is streaming through over Wi-Fi to my host PC. So again, this is just a nice kind of visual client that shows us various GPS satellites and whether or not they are used for the purpose of the GPSD daemon. I think there's probably thresholds on the SNR that you get out of particular satellites, I assume. I actually don't know the intimate details there, but for the most part, this is a great tool to kind of visualize whether or not your GPS is getting good signals to given satellites. I noted that with any of these clients, when I'm indoors in my skyrise apartment where we get really poor satellite signal, I only get like 1 or 2 satellites with SNR values of like 0, basically. So they're not used. So it's not until I actually take the quadcopter and GPS module outside do I actually get to see satellites pop up on these clients and actually get used by the GPSD software. So with that said, I'll go right on into implementation here. And the implementation is pretty basic. I won't repeat kind of what we did in Project 6, because in Project 6, we had already set up the Raspberry Pi with Motion and RASPAP. We already set up all those components on the quadcopter. I decided to leave those fully in place. This time, much like last time, we are streaming and viewing GPS data on the host PC. The Raspberry Pi is set up as a wireless access point, and I'm able to access the Raspberry Pi through VNC Viewer through the static IP address that is set up through the wireless access point. So upgrading the quadcopter here, again, it's already set up with all the components that we need. I just decided to mount the GPS module on the left side of this image here. It is actually the opposite side from the battery that is powering the quadcopter motors. So I could try to balance the weight out as best I could. I had already had kind of the weight of the quadcopter already leading off to the right-hand side here. So any weight I can put on the left-hand side is good to counterbalance and just lead to better drone performance in general. The one instruction that I understood from this GPS module is to mount it such that the flat silver sticker side is pointing upwards to the sky. And so that is what I made sure to do when mounting it on the quadcopter. And that's kind of what you can see here, although it might be a little hard to see in this image. Outside of that, that's pretty much it. Battery pack, web camera, Raspberry Pi 4 with the case, all mounted on the quadcopter, nice and neat. Another couple images here, you can see the webcam in full view, the Raspberry Pi with its various ports. I made sure it was in a nice, convenient location. The battery pack is this red, shiny box here that provides enough power output to supply the Raspberry Pi, so it doesn't get any undervoltage or anything. And you can see here the G-Mouse GPS module pointed upwards towards the sky. And so that's basically it for the system description. I'll go ahead and cut here and we'll jump straight into the demonstration video. Thanks so much.